Can you guys see my screen?
Yes.
Right. Right. So today's lesson is about ratios, rates, and proportions. Right. So we're going to see what every one of those is, and also see how to use them to solve some problems with missing quantities. So let's go ahead and start with the ratios. So a ratio is basically when we have two quantities or more that are related. Let me write that again. So ratio. A ratio is when two quantities or more are related. For example, let's say when you go to a grocery store or something and you see, for example, two items for, let's say, $7. Okay, so this is what we call a ratio here. In this case, we have two quantities. So 2 for 7. We could say it in multiple ways. So a ratio can be written and said in multiple ways. You can either say 2 for 7. You can say 2 to 7. This is the actual expression of ratios. We say 2 to 7 or 2 colon 7. These mean the same thing. This is the actual symbol for the ratio. When you see this between numbers, it just means those numbers are related. They form a ratio. They're not random. For example, here the items and the prices could be students and grades or something like that. So the bottom line is these two are related. What else? We can also use an arrow to express that ratio, say 2 to 7, like this. Another one. This is probably the one we're going to be using the most. It's easier and it makes sense when you use arrows like this. You can also express this as 2 by 7, for example. 2 by 7, another way of expressing ratios, or even as a fraction, you can say 2 over 7. So we're mainly going to be using this notation and also fractions because ratios, the easiest way to deal with them is to turn them into fractions. So all these are basically just notations. Of related or ratios. And the reason they're related or they form a ratio because it's basically like a formula. Let's say if you buy two items, that's going to cost $7. What if you want to buy 4 items? How many would that cost? Based on the this ratio here.
14.
That's right. If you double the quantity, you got to double the price, and it will be 14. So this ratio is like the base formula for whatever, however many items you want to buy. So you can look at this and see how much, let's say you have a bunch of money, you want to know how many items you can get, or you want to get a certain number of items, you want to figure out how much money would that cost. So basically you go by this base formula to figure things out. And that's pretty much the main idea about ratios, just related quantities. Could be 2 or more quantities. Let's an example when we have ratio made of more things. Let's say, it's a random example here. Let's say cooking, for example, a cake. You know, a lot of ingredients go into cooking cakes. So it's just assume we have 3 ingredients for this one, maybe. So to make one cake, maybe let's say 3 eggs and maybe 2 cups of maybe flour. Okay, so 1 cake, 3 eggs, cup of flour. So this is, again, these quantities are related, so this is another ratio. And so this is to make 1 cake. But if you want to make 2 or 3 or more, so you got to adjust your ingredients accordingly, or we're going to talk about later during this class, proportionally. So you're going to adjust these quantities proportionally depending how many cakes you want to make. For example, you can't just increase one ingredient and not increase the other. It's got to be out of proportion, and your thing's not going to taste as good. Okay, so proportions and ratios go hand to hand because, again, it's a formula, a base formula that we use to adjust quantities, either increase or decrease them based on the main ratio here. Okay, let's say, for example, this cake here, I don't know, let's say you have, let's say we have 10, let's say we have, I mean, not 10, but 6 eggs. How many cakes can you make if you had 6 eggs? So this is again cake. The second one is for eggs. Second one is cups of flour, for example. Let's say you happen to have 6 eggs and you want to figure out how much of the other ingredients do you need. So if you have 6 eggs, how many cakes will you be able to make and how many cups of flour will you need based on this?
2 cakes and 4 cups of flour.
Exactly. So these are eggs. If we have 6, looks like we double the numbers of eggs. So we're gonna have to double the other ingredients. So automatically, so it's gonna be 2. So you gotta adjust these as well and adjust that. Double this, it will be 4. Again, if you just add too many eggs and not adjust the other ingredients, um, it's not gonna work out. It's gonna be a totally different thing. So ratios matter. Quantities are related, and once we know the base ratio, we can turn it, or we can find other quantities or ratios. Um, let's see another example here. Okay, so most of the time you'll see an example or a word problem written like this: 2 items for 7. So to turn it into a ratio, again, you can use any of these notations. Very simple. But again, we're going to be using this a lot, the arrow, and also going to be using the fractions. Let's see how to simplify ratios. Sometimes you may have, let's say 15 items for, let's say, 5, or maybe 10. So the ratio here is obviously 15 to 10. I can write it first like this, 15 to 10, or as an arrow, 15 to 10. But again, this looks like a large quantity. Is something, for example, in bulk. But let's say you're not interested in buying this much. Let's say this is whatever, something that's too much for you to buy. But we can try to simplify this and reduce it in order to get some smaller numbers that we can make sense of. This is, for example, let's say you're buying some groceries for a party or something, and you need a lot of. This is displayed on the market like this, but you just want to have enough for one person or 2 people. So you're going to try to reduce this to something that makes more sense, something around what you need to buy. So just like we saw with fractions, we can take ratios and reduce them. So 15 to 10, we can write as a fraction, as we said earlier. Once you have that fraction, you can reduce it, make it smaller to make more sense. So How can we reduce this fraction or this ratio?
Can we turn it into a mix?
If,
No.
before mixed numbers, can we make this fraction smaller? Can we reduce it to the lowest terms as we saw before with fractions?
Be
Can
over
you
two?
divide by 5?
That's right, we can reduce it by 5. That's right, so we learned how to reduce fractions before. This is 5 times 3, and 10 is 5 times 2. So we cancel this. So this is a much simpler ratio. So instead of this, now we can go by this ratio, which is again the same ratio, the same formula, but this makes more sense for us. Let's say, you're only 3 people and you need some items, or uh, you 2 people and you need, for example, 3 items or something like that. So this makes more sense. It's still the same formula here, the same ratio. They are related, they are proportional. Um, and this is a reduced ratio. Okay, so write it as a fraction and get the lowest ratio possible to make sense of. And once you have your basic ratio here, you can either buy more than this, or you would know, let's say you want to buy 300 items or something. You can just multiply this by 100, this by 100, or you can buy less, depending. So you want your ratio to be as simple as possible, uh, just like your basic formula that you can use to go back and forth between larger or smaller quantities. Okay, so you find the largest number that can go into both, reduce that, and you get yourself a reduced fraction, uh, therefore a reduced ratio. Um, and the unit here could be any units. Let's say it could be dollars, it could be ounces, it could be miles, whatever the units or the quantities might be. The method, the mathematical uh, procedure is the same. The units might change, but the math is pretty much the same. The notation is also the same here. And the units are just symbols of whatever quantities we're dealing with. Okay, so you may see in the homework, you may see like ratios, and we'll be asked to reduce them to the lowest terms or something like that. Let's say 14, let's say 14 hours. For let's say, no, this probably doesn't make too much sense. Let's make it like this. Okay, just some random number I made here. Let's say someone worked for 14 hours and they got paid this much. Okay, so two things we can do here. We can reduce this to the lowest term possible, or we can even find the rate or the unit rate. For example, usually here for hours, you know, this is 14 hours for 210. You want to probably find the rate of 1 hour. That's what we call finding the unit rate. Um, First, let's reduce this. So the first question might be write as a ratio to the lowest terms. Okay, so what would this be as again as a ratio? 14 to 10, which we can also write as a fraction. So in order to reduce a ratio, write as a fraction and start basically reducing it. what do you think? How can we go about reducing this ratio to the lowest terms? What number is the highest number that you think goes into 14 and 210? We can probably do 14 here, or 7 times 2. For here, we can do 21 times 10, right? 21 times 10. And after that, we can get, as you can see here, we can get a 7 from here. So we can say that 7 times 3. And you can also turn this into 5 times 2. So what we called factoring when we did fractions, we factor, and cancel out. So we can cancel out the 7s, and we can even cancel out the 2 here and the 2 here. So what's left here is basically 1 over 15. What is this? What does this represent, 1 over 15? It's basically the
$15 an hour.
Exactly. So this is the unit rate we talked about. So this is the same as 15. Okay, so this ratio is the same. So now it makes more sense. When someone tells you made 14 or 210 in 14 hours, you're probably not gonna wrap your head around it, how much exactly that is. But once you reduce it, now it makes more sense. So now you can take this, let's say if I work 40 hours, I'm just gonna times this by 40, if I work 30 hours and so on. So this is the coincidentally, that's, I believe, the minimum wage in New York City right now. It's probably 15, right? That's what you can say an hour per $15 per hour. So this is what we call the unit rate. When you see 1 in the ratio, that's called the unit rate, but it has to be 1 on one of the sides. For example, 1 hour costs how much? What 1 mile requires how long or how much gas or something like that. So what we call the unit or the base rate or whatever it's called. Again, you can easily get that by reducing your fraction. And again, these may change. You may see instead of hours and dollars, you may see miles and hours, or may see items and some other things. So there's got to be some units, but the method again of reducing this is the same. Okay, so it may also involve some geometry. Rectangle here, for example, the width is 10 and maybe the length happens to be 50, maybe let's say feet here. Same thing here, feet. So let's write this as a ratio first. It's like here, write as a ratio, and also reduce it if possible. By the way, when you write a ratio, you can say 10 to 50 or 50 to 10. It means the same thing. It's no big deal. You can say, 14 hours for 210 or 210 in 14 hours. It means the same thing. Either way, it will be fine. So we can write the ratio as 10 to 50. Can we reduce this ratio?
Yes.
Okay, first we're going to write it as
Fraction.
fractions, right? Either way is fine. 10 to 50.
And then divide by 5.
That's right, divide by 5, or even better, divide by 10. And it would be 1/5. So 1/5 or 1 to 5. And whatever.
Professor, I don't understand that one. 10.
This one, so just, so we have a rectangle. So we have 10 to 50. So we just want to see the ratio of the width to the length. So this is the width of the rectangle. This is the length. The question is, we'll say, what's the ratio? What's the ratio
What do we choose?
Hello, akabala chikochi.
Okay. What's the ratio of the width to the length? Or the other way. So this is what the question would say. What's the ratio of width to the and then the question say reduce or if possible. Okay, so again, one quantity to another. You can write it this way as a fraction, reduce it. So now we're back to this. And again, this is what we can call the unit rate. So 1 foot from the width is equivalent to 5 feet from the length. In other words, if you increase this, you have to increase this one accordingly. We have whatever this is. Let's say this is maybe a garden or a piece of cloth or a towel or whatever. So
The result is 5 equal 5.
This one was on a 2, 5. This is like this. Okay.
Okay.
2 points, 1 to 5. So this is the symbol of the ratio, the colon. Okay, we'll call this colon. Or we can use, like I said, the arrow 1 to 5. 1 to 5, they all mean the same thing. So let's say you have this, let's say you have this, maybe a picture. You want to frame a picture, panoramic picture, and let's say the ratio is 1 to 5. 1 foot by 5 feet. This is probably a large poster, panoramic poster. Let's say you want your poster to have a width of 2 here. So you have to increase this accordingly. You can't just increase one dimension and not the other. You will have a distorted image. Okay, imagine when you expand one dimension of the picture, when you drag one side and you distort the picture and it looks weird. That means you have to increase both dimensions proportionally. That's the key, proportionally. So let's say you want that picture or that poster to be, for some reason, we want it to be 2 here, 2 feet. If it's 2 feet here, how much do you think, or how long will this be? If it's 2, if you want to make it 2 feet wide, what's the length here?
5.
10.
Not 5, but 10. 10 is right because 1, we doubled the width. We gotta
Equal 10.
double the length as well. So this turns into 2. Basically, we times this by 2. We gotta times the other one by 2. So it's gotta be 2 by 10. 2 by 10. Yeah. Otherwise, your poster will look weird. Okay. You will have like people with, I don't know, longer legs or whatever. Because if you increase one size or one dimension, not the other, the image will look weird. So you want to increase both dimensions proportionally according to a specific formula, which is this, not randomly. What about if you want to make this 3 feet? You're going to make this width 3 feet. How much would, or how long will the other side be? So 3 feet. This would be, make 3 here. What would the length be?
It's 20.
Not 20. Say it again.
20.
Not 20. So we turned 1 into 3. That means we times this one by 3. So we got to times the other one also by same number, which is 3.
15.
That's right. Will be 15 here. Okay. So again, think of it as a picture. So you have a small picture, you want to put it on the wall, but you want to make it bigger. So if you have a small family picture, but you want to make it a lot bigger, so you take it to a place, to a studio where the scan it and increase the size and quality and stuff. So the shape will still be the same. See how it's rectangular? You will never change the shape, for example, like this or square. You're just going to be one smaller version of the other. It could be as small as this, for example, just like you zoom in and out of something. But if you increase it, it may look bigger, but it's still the same shape, still a rectangle. It will never change from a rectangle to this. If you change this to this, then you distorted the dimensions. It will not be proportional anymore, and the picture was it's going to look weird. Okay, so that's the concepts of ratios and proportions. Okay, so ratios and proportions. A ratio, when you change it, you get something proportional. And the rate, again, is when you find the price, for example, of one item, or the rate of 1 hour, or the length of, or the time you need for 1 mile, or something like that. So it's always going to be one on one side of the ratio to get the unit rate. Okay, everybody, does that make sense?
Yes.
All right, everybody else, do you guys have any questions so far before we move on?
No.
Okay, so proportionality. Let's see if we can look at another example. So sometimes we, so again, when you have a ratio, you can change it as you want. You can either multiply by the same number, or you can even divide. So when we reduced it, as you can see, when we reduced here, we divided by 10. Okay. You can also, if you want to make this bigger, you times by the same thing. You times it by 2 and by 2, we get this. Times by 3 and by 3, we get this. So as long as you do the same thing on both sides of the fraction or the ratio, you get an equivalent ratio. If you remember when we did fractions, any fraction like this, if you multiply the top and bottom by the same number, whatever the number might be, for example, C.
Maybe 30.
So you get a new fraction, AC over BC. We call them equivalent fractions. So as long as,
Equivalent.
that's right, as long as you multiply the two sides of the fraction by the same number, or the ratio also by the same number, either multiply or divide, you can even divide, like we did here, you get something equivalent. We called these equivalent fractions before, but today, since we're talking about ratios, we can call them proportional ratios. Okay, if you're dealing with fractions, we call them equivalent fractions, but with ratios, we call them proportional. For example, this one is proportional to this. So this, also this one, is proportional to this, because this money is steady. If you work, I don't know, 100 hours, you're gonna 100 hours here, the money you're gonna get is still gonna be based on this. You're not gonna get any more or less. It's gonna be, you're gonna be paid based on this ratio. If the hours change, the money will change proportionally and accordingly, according to this ratio here. Just like the concept or the analogy of a picture. You have to, if you increase one side, you have to increase the other to keep the ratios and to keep the picture looking normal. Otherwise, you're going to distort, like I said, your picture. It's not going to look nice. So ratios. Now let's talk about proportions. So okay, we can call this, so over here, basically we did the rates. Okay, so the unit or the rate is basically when you find the cost or the rate of 1 hour or whatever. And the first one we did the ratios. Now, The ratios, rates, now we're going to talk about proportions. This would be number 3. Let's say, back to another problem here with
Decimal.
let's say 3, 4, 7. Whatever this might be, whatever units, 3 equals 7. What happens if I have 14 here? What's the missing quantity here?
6.
6. That's right. Because this one doubled, this one has to double as well. Goes from 7 to 14. We changed 7 to 14. How did we change it? So you do a lot of math in your head. You say, oh, this was multiplied by 2. If you multiply this by 2, you got to multiply this by 2. Again, just like a picture. If you increase one side, you got to increase the other. Otherwise, you won't get the same picture. So this also times 2. So you're going to get 6 here. So now these two are proportional, okay? These two ratios. So this is a ratio, another ratio. Together, if you make them right, if you increase them accordingly, they make proportion. So these two ratios are proportional or proportionate. You can also say they pretty much mean the same thing. Okay, proportionate. Okay, in other words, these two increased proportionally. If you need the adverb, this is the adjective. We're describing these ratios, they are proportional. Or you may say, if you want to be a little fancy, use bigger words. You can say this ratio has changed or increased proportionally. That means we changed this one with a certain rate, and we changed the other one with that exact rate, which is times 2. If you times this one by 2 and this one by 7, then your two ratios are not proportional. You're just making stuff up. You can't rely on it. And to check, there's a way to check whether actually two ratios are proportional or not. And this is what we're going to do now. So checking. Let's check some for proportionality. If you look at these two here, if we cross multiply them, the cross multiplication will be equal. Let's take a simple example. So let's say 1, 2, 3 to 1. Let's make this 3 to 1. And let's make this, let's say, I want to make this 9. So this ratio, what's the missing number here? So these two are proportional. 3 to 1 is the same as 9 to 1.
9 to 3.
9 to 3. That's right, from 3. Because this what happened to it. We multiplied it by 3 to get 9. We're going to times this by 3 also to get, by 3 we get 3. So these are proportional. And this is where, so what we do to check proportionality, we cross multiply. So we start with this, 3 times 3. It must be equal to the other multiplication, which is
This
9.
one is 9.
Um,
3 times 3, 9.
3 times 3, that's right, and 9 times 1. These must be equal. When you cross multiply, both sides must be equal. Otherwise, it will not be proportional. It will be something different. So this is 9. This is also 9. So you say, yes, they're proportional. Okay, so yes, they're proportional. So just cross multiply, just like we do with fractions. If you want to write them as fractions first, you can also do 3, for example, over 1. And it should be equal to 9 over 3. Same thing. Okay, so if you cross multiply, now it would be 3 times 3. It's like this. And then 1 times 9 would be 9.
9.
Okay, so you cross multiply to find out whether two ratios are proportional. If they're not proportional, then you cannot use them. You cannot rely on them. Let's say this was some cooking recipe. Let's say, I don't know, 3 eggs per 1 cake. So this we can rely on. But if you have, instead of 9 here, you have I don't know, 11, and you have 3 here, then this is not proportional. It's not proportional. These ratios are not proportional, so you can't use them to do actual stuff like cooking or doing changing pictures dimensions. It will be just some random numbers, unreliable, just not proportional. Here's another example. Let's say couple of examples actually, 2 to 7 and 3 to 5. And also maybe 4 to 5. And okay, check. Check proportionality, just like these problems. So we have these two ratios here. We don't know yet if they're related. We don't know yet if they're proportional. What should we do to find out?
Like 2 times 3, 6 plus 1.
Not 2 times 3. We need to cross multiply. Okay, we need to cross multiply. So what do we multiply exactly?
We multiply 3 times 7.
That's right. So we cross multiply.
Yeah.
It's like a cross like this. That's why I call it cross multiply. So 3 times 7.
21.
We say, is it equal to? What's the other multiplication?
21.
5 equals 5 times 2.
That's right. So we did this one, and the other multiplication, 2 times 5. So times this and this, that's the cross multiplication.
4 times 7. 5. Okay.
Okay. Are they proportional? So this is 21. This is 10. So what do you think about these ratios?
Multiply.
We
They're
did.
not proportional.
And be divide.
So what can we say? What can we conclude about their proportionality?
That they're not proportional.
Exactly. They're not proportional. Because when you cross multiply, so this is not something to go by. This was about 2 items for 7. 3 items are not gonna cost 5. This is some random stuff. If I don't know, if you need two eggs and I don't know, 7 tablespoons of butter, it's not gonna be the same as 3 or 2, 5. So this is not unreliable. So you say not proportional. What's the word? What's the opposite of proportional? Proportional. There's a one word. It's one word that's the opposite of this, of proportional. What is it? When something is not proportional, it's
It's not proper.
It's this.
Is this position?
Is proportional. Okay, this is proportional or disproportionate. Okay, so when you add this prefix, just means the opposite of proportion. So these are disproportional or disproportionate. How about these? Are these proportional or not? These two ratios.
No.
Yes.
Okay. Justification or explanation. Why do you think so?
8 times 5 is 40, and 4 times 10 is 40.
That's right. So we start by cross multiplying 8 times 5. And we're going to say,
40.
is it equal to the other multiplication?
10 times 4, 40.
They're both 40, so that's good. Both 40. And you say yes, they're proportional. Unlike this one, this is some random stuff again. It doesn't work that way. So this is not reliable, but this is reliable. So if you can buy 4 items for $5 something, for example, you know for a fact that you can buy 8 items for 10. But this one is not reliable. It's misleading. It's not. These two ratios are not proportional. Well, that's does it make sense, everyone? Any question?
So it is proportional when you could multiply both numbers.
When you get two equal numbers here, yeah. I mean, when you get two equal numbers like this, you say proportional. But
Okay.
here, this is not proportional, so it's not a true relationship between those two ratios. They're disproportional. Okay. And let's see.
Wait, can you also just do division?
Can you do division
Right.
of the two like this?
No, in the rate, when you did 14 hours for 210.
You can do the division, yes. If you're looking for, that's right. If you're looking for, if you divide this by this, when you're looking for the unit rate, yes, you divide one by the other. But if you're just reducing it, for example, here, we didn't divide, we didn't have to divide 3 by 2. We left it like this, 3 to 2.
Okay.
This is the reduced, the lowest ratio. But if you want to get the unit rate, you divide this, it will be 1.5. Okay, so if you divide them, you get the unit rate. It's a fraction, decimal here. But if you just want to reduce the ratio, it doesn't matter if you have 1 here. So basically what this means is, this is basically 1.5 to 1. So 3 over 2, if you divide them, so you get basically this amount, and you have 1 on the other side. So this is the unit rate, or the price of one item, or whatever the units might be.
Which 7 times
Okay,
4.
so if you're looking for unit rate, divide. If you're looking for unit rate, divide one by the other. If you're not looking to, if you're just reducing, if the question says reduce the ratio, then you don't have to divide one by the other, but write them as a fraction and reduce them. Divide them by the same number.
Okay.
That's the difference.
And way 2?
Say that again?
And way 2, you divide or you multiply? For 14 and
For
210.
14, if you're looking for the rate, divide right away.
Yes.
Okay. Here, we were just looking to reduce the ratio, but it turned out to be also the unit rate because you have 1. If you have 1 on one of the sides of the ratio, that's the unit rate. But again, if you're looking for the rate, divide one by the other. If you just want to reduce, do this until you get the smallest number possible. Okay, so
Okay.
ratios are very useful. I mean, it's not only for this math class, but it's something that you kind of use and you do want to use daily, whether you're shopping, you're cooking, you're doing a lot of things. Understanding this can make your help you make better decisions, whether it's financial or other stuff. Can be very handy. Any other questions? Okay, so so you should be familiar with the basic formulas. For example, one of these has one of that. All the units that measurements that we know. So we should be familiar with some basic formulas like these. So units of measurement. So conversions between units, and sometimes we need to convert from one version to the other. We call this number 4. For example, 1 pound has how many ounces? A pound is how many ounces exactly?
16.
16, that's right. 1 foot is equal to, in inches.
8 times 2.
Now 1 foot in inches is
12.
12. What other commonly used units? 1 yard. How many feet are in 1 yard? 1 yard is?
24.
1 yard is 3.
3 feet.
Mm-hmm. Is 3 feet. So these are some of the units that we need to be familiar with. Okay, just the basic ones. You should know how to convert from this to that. Of course, we all know that 1 hour is how many minutes? Of course, is 60 minutes and so on. So we need to know the basics. Why? Because sometimes, let's say you have, I don't know, 3 pounds, you want to find out. So how many, you want to find out, let's say you have, so you said 1 pound is, what's said here, ounces. Let's say you have 2 ounces, but if you have 2 pounds or more, we may say like how many ounces are in, let's say, in 3 pounds. This is a symbol for ounces. This is a symbol for pounds. So how would you fix this problem? So we need the base formula, the base ratio, or the unit rate, as we talked about earlier. There's 1 on one side. So that's the unit rate. So how many ounces do you think are in 3 pounds? So to figure this out, what you do is, first you need to know the base formula, okay? You need to know it in your head. So you say 1 pound is 16, okay? You say 1 pound is 16 ounces. So let's put pounds on this side. And let's put ounces on this side. Now we have 3 pounds, so it's going to go under pounds here.
8.
That's right. So now we're missing this part. So we need the basic ratio first. So in order for these, so what is the missing quantity here? what happened to from 1 to 3? So how did we get from 1 to 3? We times it by
3.
3. Okay. And to go from here to here, we're going to times by
2.
no, not
Is
2.
it 3?
8
Right.
times 2.
Same thing. You're going to times by 3.
2.
And that's how you find your missing number here. 6 times 3, that's
Oh, 6 times 2.
That's 48, right?
Oh, 48.
And that's it. So this is going to be that. So again, know these. You have to know these. Get familiar with them. And you can switch back and forth. Any problem basically using ratios. Go right to ratios, figure out the missing number. Let me give you one more example here. How many yards are in, let's say, 18 feet? How many yards are in the 18 feet? You may figure it out right away. That's good if you do. If not, first you're gonna write the base formula. What is the base formula for the base ratio for yards and feet? What to what?
Is 9.
What is the base formula first? The common formula between.
1 times 9.
1 yard equals 3 feet.
That's right. So you gotta know this formula. So you gotta write it down, and you're gonna base the conversion on it. So 1 yard. 1, 2, 1, 2, 3. Okay, 1, 2, 3. Now, what is the other ratio? What's missing? Are we missing the yards or the feet? This is the yards here. This is the feet on this side.
Yards.
So what goes here? Do we know this quantity?
6.
We don't know it, right? That's what we're looking for. So
We don't know yet.
okay, might be 6. And here we know this part. We know the feet. That's 18. So basically, this changed from this to this. The other one has to change proportionally. How did this one change from 3 to 6?
6 times 3.
That's right. 1 multiplied by 6. You got to multiply the other one by 6 as well. What is the missing quantity here? 1 times 6, which is 6. And you can double check to see if they're proportional. How do you double check proportionality? What do you multiply?
Cross multiply.
Exactly, cross multiply. You gotta say 1 times 18 is it equal to?
18. And then 6 times 3
That's right.
is
So
18. So it is proportional.
that's right. So we got the right conversion here. If you cross multiply, something is odd, that means you didn't convert right. You try again. And this is just for feet and yards. Could be any other units. It's the exact same way. The units might change. But again, get yourself familiar with the basic units, basic conversions like these. There's a list of them in the book. You can also find a chart online, like basic ones, basically, not the large numbers or different units, just the ones we use frequently. What else? Any questions, everybody? Any questions?
I have a question about the unit of measure.
Units of measurements.
Yeah.
So these are the units. The unit, for example, pounds, ounces.
Like the chart.
Hello. There's also other
Absolutely.
units like meters. There's grams. There's liters. So that's what I mean by the units of measure, we use them to measure something, whether it's length, volume, weight of something. We use them to measure stuff. So we need to know at least these basics here. For example, when someone says a pound, you now should know it's 16 ounces. Foot is 12 inches and so on. Or you can also use, these are basically American units, but internationally, instead of these, we use meters for length, we use grams for weight, and we use liters for volume. I don't think we're going to be seeing those, but if you see them, it's the same concept. Basically, you can convert from one to the other. Okay, these are international units. Again, this is for the weight. I mean, M is for meters, that's for length. Grams for weight. And liters, of course, for volume. But again, in America, instead of meters, we use feet and inches, miles, and so on. For weight, we use ounces, pounds, tons, and stuff like that. For volume, we use liquid ounces, we use quarts, we use gallons, but internationally, you use the liters for measuring volume. The scientific community they all agree on these international units. So if you go to Europe, places in Europe or somewhere in Africa, or most other places in the world actually use international units. So you may not see these in supermarkets or grocery stores. Say this and this and this. So it helps if you know your basic conversions. So at least you can do a little conversion in your head and know what they're talking about. And that pretty much concludes our lecture for today for ratios, proportions, and rates. We're going to be using these concepts and formulas in the future to solve word problem. We did some of it today, but we're going to do more of these. Some of this like that. We're going to do more of these. We'll be given a word problem and it will say find this and find the missing quantity. It's going to be pretty much like this, using ratios and cross multiplying.
And the number 4 is unit of what?
I'm sorry.
It's units of
Measurement.
measured. Oh, sorry, don't understand.
This is unit of measurement or unit of measure.
Yeah.
Yes, S.
S. So,
units of measurement. It's just a few of them. Measure everything. You guys can check out. If you need any formula, basically just type it in, just Google it and say pounds to feet, pounds to ounces, or for the feet to inches, whatever, and it'll give you the formula right away.
when you say how maybe odd are in 3 libras is odd
Yeah, this is how many ounces.
ounces.
Yeah, so OZ is the symbol for ounces. Let me.
Ounces. I say okay. Ounces.
I'm missing an N here.
Fully.
Okay, ounces. So there's plenty of units, like I said, you can convert a lot of things.
Convert, no?
This is
Libras. right?
This is the yeah, maybe yeah, that's what you say for pound. Libras, what is it?
It's libre, right?
Probably, I think so in Spanish. Yeah. So this stands for, yeah, this is for pounds, yeah, and OZ is for ounce. I'll post.
Thank you.
So I'll post this video sometime soon. But meanwhile, there is an older one.